Hello students, let's do congruency. Congruent triangles, exercise 21. Exercise 21 is on page number 228. Question 1. State whether the pairs of triangles given in the following figures are congruent or not. So we have many figures, many pairs, and this is the first question where we have a pair of triangles and we are asked whether these are congruent or not. Now please go through the introduction video where the conditions of congruency are explained in detail. Now these are the 5 conditions of congruency. That is, if these conditions are met, then we say that the two figures, the two triangles, are congruent. So there are 5 conditions. Any one of these conditions, if the two triangles satisfy, then we say that they are congruent. Now the first one is side, side, side. Then we have side, angle, 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 side. And we have right hypotenuse side, that is right angle, hypotenuse and side. Now let's see what's given to us. We have been given two sides for both the triangles and we've been given a right angle. So which of these conditions can we apply? We can apply the right angle hypotenuse side RHS. So let's see if we can apply this because it is a right angle given to us. The box indicates that it is a right angle here at this vertex. Now right angle, so both the triangles are right angles, that's correct. Now hypotenuse, let's look at the hypotenuse. Which is a hypotenuse? The side that is opposite the right angle. So this is a right angle, the side opposite is this. What is the measurement of this? It's not given to us. Whereas look at the other one, the hypotenuse is this side and it's given as 4 centimeters. So here, for one right angle triangle, the hypotenuse measurement is given. For the other one, we don't know the measurement. So that means we cannot use this condition. We cannot apply this. That means these two are not congruent. So the corresponding sides are not equal. So we don't know the measurement of this hypotenuse. So it cannot be the same as 4 centimeters because this is the side that is mentioned. So the corresponding sides are not equal. So we cannot apply RHS. So the given triangles are not congruent. Question 2. Now here we've been given a triangle and another one here. We have been given the measurement of two angles. Here the measurement of only one angle, and we've also been told about the sides. So here the side with two strokes and this side, the side with two strokes, are equal. So we have one side that's equal. Now here we have side with three strokes and here side with three strokes. That means these corresponding sides are equal. So we are going to try and see which condition we can apply. Now here there are two sides. So let's see if there is some condition with two sides. So here we have the side, angle, side, the second one, side, angle, side. Can we use that? Now when angle comes in between side, angle, side, that means we are talking about the included angle. Now look at this figure. Here we have two sides and the angle here is called the included angle because it is in between the two sides. Whereas here we have two sides but we don't have the measurement of the included angle. But we have been given measurement of the other two angles. So let's find out the measurement of the included angle. Then we can say whether these two triangles are congruent. Now how do we find the measurement of the third angle? Now here we can use the property which says sum of angles of a triangle is 180 degrees. We have learned this earlier, isn't it? So let's find the measure of this third angle. How do we do that? The third angle will be when you add up these two and you minus it from 180, you get the third angle. So let's do that. So that will be 180 degrees minus when you add up this. So 40 degrees plus 30 degrees. So that will be 180 degrees minus 40 plus 30 is 70, which is equal to 110 degrees. So that means we have found this to be 110 degrees. Now can you see there are two sides and the included angle. Here also we have two sides and the included angle, and both the triangles, the corresponding sides and the included angle are equal. So we can say in the two triangles, the corresponding sides and included angle are equal. That means these two triangles are therefore congruent. And what is the condition we used? SAS, side, included angle, side. Question 3. Here we've been given two sides and an angle, two sides and an angle. Let's look at all the conditions. So two sides and an angle. Let's see which condition is there with two sides. So we have side, angle, side. That means we're talking about an included angle. Now let's look at the first triangle. We have two sides and an included angle. Okay, so that's correct. Now look at the other one. We have two sides, but we don't have an included angle. The included angle should have come here. It should have come this side. This is the side where the included angle should have come. But the angle that is equal to this angle has come here. So we don't have an included angle. We have two sides, but we don't have an included angle here. So these two triangles are not congruent. So in the two triangles, the corresponding sides are equal, but the included angles are not equal. Here we have an included angle. Here we don't know whether there is an included angles measurement is not given to us. So we don't know about that. So in this case, we say that the given triangles are not congruent. So here now in the fourth question, we've been given two triangles and we've been given the measurement of the side. Which condition can we use? There are three sides. So let's use the first condition, side, side, side. So as you can see, we have 4 centimeter, 4 centimeter, 5 and 5, 6 and 6. That means the three corresponding sides are equal. Therefore, the given triangles are congruent by SSS. This condition. Okay, question 5. Again, we have two triangles. Now here, as you can see, we have a box here showing it's a right angle triangle. Here also, this is also a right angle triangle. And we've been given two sides. Now, let's look at the 5 conditions. So when you have a right angle triangle, use the fifth condition, which is RHS, right angle, hypotenuse, side. So the first part, right angle, both are right angles. Now let's look at the hypotenuse. Hypotenuse is the side opposite the right angle. The hypotenuse here is 8 centimeter, and for this triangle also the hypotenuse is 8 centimeter. So even that is equal. Now look at the other side. The other side is 4 centimeter, and here also it is 4 centimeter. That means these two triangles are, the hypotenuse and one side are equal to the corresponding hypotenuse and side of the other triangle. That means they are congruent by RHS. We have applied RHS here. Question 6. Now what do we have in these two triangles? We have a side, both have one side given, and we have two angles. So here two curves, and these two curves means these two angles are equal. One curve and one curve, these two angles are equal. Now which condition can we use here? We have two angles and a side. Now here also we have two angles and a side, here also two angles and a side. But what is the difference between these two? In this one, can you see the side has come in the middle? That means we're talking about the included side. Whereas here, we are first talking about the two angles and the side can be any other side other than the included side. So let's see which of these conditions these two triangles will satisfy. So there are two triangles. Do we have an included side? No. Included side is this side and we don't have the measurement of this side. Here also we have two triangles. We don't have the included side. That means we can use the fourth condition. Angle, angle, side. So we have two angles equal. The other two angles also equal. The corresponding angles are equal. Now let's look at the side. Here it is 6 centimeter and here it is 6 centimeter. That means the angles and the side, the corresponding ones are equal. So in the given two triangles, two corresponding angles and one side are equal. Therefore, the given triangles are congruent by angle, angle S condition. Question 7. Triangle ABC in which AB is 2 centimeters, BC is 3.5 centimeters and angle C is 80 degrees, and triangle DEF in which DE is 2 centimeters, DF is 3.5 centimeters and angle D is 80 degrees. Now there are two triangles. We have to say whether they are congruent or not. So let's draw figures to help us understand this better. So here we have the first triangle, triangle ABC, in which AB is 2 centimeters, BC is 3.5 centimeters, and angle C is 80 degrees. Now look at the other triangle, DEF, in which DE is 2 centimeters, DF is 3.5 centimeters, and angle D is 80 degrees. Now, these are the 5 conditions. Now, what do we use? There are 2 sides and 1 angle given. So, let's see. 2 sides and an angle means we have to use this condition. Let's see whether these two triangles satisfy this condition. So, 2 sides means side, angle is the included angle, and side. Now here we have two sides, but we don't have an included angle. The included angle should have come here, but we don't have an included angle here. Whereas on the other side, we have two sides and we have an included angle. So these are not corresponding, isn't it? The sides are corresponding, but the included angle is not equal. So here in the given two triangles, the two corresponding sides are equal, but the included angles are not equal. Therefore, we say that the triangles are not congruent. Question 2. In the given figure, prove that triangle ABD is congruent to triangle ACD. So let's see that at triangle ABD, we have to prove that this is congruent to triangle ACD. Okay, so we have all our conditions here. Now let's see which we can apply to each one. So let's begin. So here we have to prove. So let's start by saying prove. And in triangle ABD and triangle ACD, when you look at both the triangles, AB is equal to AC. Can you see that? AB is equal to AC. How do we know that? It's already given to us. Two strokes are here and two strokes are here also. That means these two corresponding sides are equal, and that is given to us already. Then BD is equal to DC. That is also given to us. Can you see that BD is equal to DC? How do we know? There is one stroke here and one stroke here. That means these two sides are also equal. So we have two sides that are equal. Now let's look at the third side, that is AD. Can you see that AD is common to this triangle ABD, and this AD is also common to this triangle ACD. So we can say AD is equal to AD, and what is the reason? It is common to both the triangles. Now, the three corresponding sides are now equal, isn't it? AB is equal to AC, BD is equal to DC, and AD is equal to AD. The three corresponding sides are equal. So we can use this first axiom or the first condition SSS. So we can say that triangle ABD is congruent to triangle ACD by the SSS axiom. You can call it the axiom, or you can simply leave it as SSS. Okay, so we have proved it here. Hence, this is proved. Question 3. Prove that. Now, there are three things that we need to prove. The first one is triangle ABC is congruent to triangle ADC. So first, let's take that up and then we'll go to the other two. Let's prove that these two triangles are congruent. Now, which are the two triangles? ABC, that is ABC, that is this triangle. Then triangle ADC, that is ADC. We have to prove that these two triangles are congruent. So that's the first proof that we have to show. In triangle ABC and triangle ADC, can you see that AB is equal to AD? Where is AB? AB is equal to AD, we know, because of that single stroke on both sides. So these are corresponding sides and they are equal. CB is equal to CD. CB is equal to CD. Again, the strokes tell us that these two sides, corresponding sides, are equal, and this is given to us. So we know about two sides. What about the third side? The third side is AC. Now can you see that AC is a part of this triangle as well as a part of this triangle. So this is a common side, a side that is common to both the triangles. So we can say that AC is equal to AC, and the reason is common. They are common to both. So now there are three sides and the three corresponding sides are equal. So we can say that triangle ABC is congruent to triangle ADC because of the SSS axiom or the condition side, side, side. Because three sides are equal, so these two triangles are congruent and hence we have proved it. So we finished with the first proof. We have proved that these two triangles are congruent. Now let's go to the second one. We have to show that angle B is equal to angle D. Now where is angle B? Angle B is here, and where is angle D? Angle D is here. We have to show that these two angles are equal. So that is our second one. Now angle B is equal to angle D. How do we know that? CPCT. What does that mean? CPCT means corresponding paths of congruent triangles are equal. Remember, we learned in the beginning, when two triangles are congruent, their sides are all equal and their angles are also, the corresponding angles are also equal. So here angle B will be equal to angle D because these two triangles are congruent and corresponding paths of congruent triangles are equal. Hence, we have proved it. So when you write this, you need to write in brackets the reason, and the reason is CPCT, the first letter of each of these. So we have proved the second one. Now let's take the third one. AC bisects angle DCB. Now can you see this is angle, this is a line AC and this is a triangle DCB. So we have to show that this line is bisecting angle DCB. So the angle is here. Okay, so let me show that. So here you have this whole angle. In that, this part belongs to this first triangle and this part belongs to the second triangle. And we know that corresponding angles are equal. So corresponding angles of congruent triangles are equal. So here, as you can see, this angle C, this part, angle C has been bisected by this line. What's the meaning of bisecting? Bisecting means dividing into two equal parts. So this line AC has bisected this angle C. Okay, that is DCB. This part, it has bisected into two parts. So we can say that angle BCA is equal to angle DCA. That means this portion, angle BCA. We are only talking about the angle, not the triangle. Similarly here, angle DCA, they are equal. Okay, and therefore, AC bisects DCB. Because the two angles are equal, definitely this line in the middle is bisecting it. It's bisecting the angle into two equal parts. So we have proved that also, that AC bisects angle DCB. So that is also proved. Question 4, prove that. And there are 4 questions here and we need to prove. Let's begin with the first one. Triangle ABD is congruent to triangle ACD. So this is what we are going to write down. Now this symbol also stands for congruency. Now which are these two triangles? ABD. This is ABD. So this triangle. The other one is ACD. This is the other triangle. So we have two triangles here. The first question is we have to prove that they are congruent. Now in triangle ABD and triangle ACD, AB is equal to AC. Can you see that? AB is equal to AC. How do we know? The two strokes show that the corresponding sides are equal, and BD is equal to CD. BD is equal to CD or DC. Again, the single stroke on both the lines show that they are equal. So we have two corresponding sides that are equal. What about the third side? Now these two sides are already given to us. Look at the third side, AD. That side belongs to this triangle as well as to this triangle. That means that is equal, isn't it? So AD is equal to AD because it is common. So now can you see that the three sides of this triangle and the three sides of the corresponding sides of the other triangle are equal. That means both these triangles are congruent by the SSS axiom. So we can say triangle ABD is congruent to triangle ACD by the SSS axiom. Hence we have proved it. Three sides of this are equal to three sides of this triangle. Now, second one, we have to prove that angle B is equal to angle C. So that's the second one. Now remember, when two triangles are congruent, the corresponding angles will be equal. Corresponding sides are equal, corresponding angles also will be equal. So this is angle B here and this is angle C here. So as you can see, they are corresponding angles. So they are equal. So corresponding angles are equal. And what is the reason? CPCT. What does that stand for? Corresponding parts of congruent triangles. Remember, corresponding parts are always equal. So we have proved that angle B is equal to angle C. So right, hence proved. The third one is we have to show that angle ADB is equal to angle ADC. Angle ADB. Now where do we have ADB? It's here. Angle ADB is here and angle ADC is here. So they are corresponding angles. As you can see, both these angles are corresponding angles and corresponding angles of congruent triangles are equal. So we can write that angle ADB is equal to angle ADC and the reason is CPCT. Corresponding parts of congruent triangles are equal. Hence we have proved that also. Now the fourth one is we have to show that angle ADB is 90 degrees. That is this part. Can you see angle ADB? We have to show that this is 90 degrees. We have to prove that. Now angle ADB, that is ADB, plus angle ADC will be equal to 180 degrees. Why? Because they are a linear pair. Now look at this. If I take this side also, together they should give us 180 degrees because that's what we have learned about linear pair, isn't it? That on a line, when you have two angles, they should add up to 180 degrees. And that's what we've written here. So you have to write the reason. The reason is they're a linear pair. Now remember, we just showed here that angle ADB is equal to angle ADC. Angle ADB is equal to angle ADC. Now, when we have to find angle ADB, we will write it as it is. That is, we're going to say angle ADB plus angle ADC, isn't it? Instead of angle ADC, I'm going to write angle ADB again. How can I do that? Because both are equal. So I can write angle ADB again. So this will be angle ADB. Together they add up to 180 degrees. So here you can see there is one angle ADB and one more angle ADB. So together they make up 2, isn't it? So 2 angle ABD is equal to 180 degrees. So if two angles of ADB is equal to 180 degrees, let's find out how much one angle will be. So that will be angle ADB, we'll leave it as it is here, 180 degrees on the other side, and let's transpose this 2 to the right hand side. So when we transpose, it becomes division. 180 divided by 2. How much is 180 divided by 2? 90. So that's 90 degrees. So here we have got angle ADB is now equal to 90 degrees. So that was our fourth question. We had to prove that angle ADB is 90. That means this is 90 degrees. We have proved it. So hence proved. So we need to write hence proved. So children, we'll stop with this for now. In our next video, we will continue with the remaining questions. Thank you, children.